So let's first off look at the hardware, just so you get a better understanding of how the thing is put together. And here I've got a pretty old computer. Actually, it's two computers. If we take a look down at the bottom, we can see that we've got a standard PC with its own associated hard drive. And if we come around to the other side, you'll see I've got a second computer. This is actually a Motorola 68020, and it's only got 2 megabytes of memory, and at the top it's got its own 40 megabyte hard drive. Both of these share the PC case and the common power supply.
Okay, so everything is now rewired and the Windows XP has started. As I said, the PC side of things only has to handle two functions. One is to act as a console to my Motorola 68020 board, and the second thing it needs to do is emulate a man-machine interface that ABB produced a long time ago called the Tessellator, which is my man-machine interface for the SCADA system. So the first thing we'll do is we'll fire up the console emulator. In this case I'm using Alpha Term. And if I make a connection to the board, you can see that we get a boot menu, and the first thing of course I want to do is boot from hard drive. So choose that option and we will hopefully find the SCSI. There we go. And this process will take around about 10 to 15 seconds to boot into the operating system. That's complete, and now we're booting the SCADA system. This will take a little bit longer. We've got a lot more to do here. What we're going to do is load most of the system into primary memory, and that includes the database, the drivers to the graphics system, the drivers for data acquisition, plus any other drivers we need. We're going to load background programs such as alarm event handling, historical logging, etc. And as you can see, as those background processes get loaded, we get the plus numbers coming down the left hand side of the screen, very similar to the way things happen in Linux or Unix. And the most CPU intensive thing we're going to do is load all the calculation tasks, and we've got quite a number running here because it's a demo system. So that took, I don't know, maybe 30 seconds, and the system is up and running. Straight away you can see we've got a failure, and that is that we can't connect to the graphics system, and that's not surprising since I haven't started it yet. The SCADA system will look for a valid graphics system. When it finds one, it'll bring it online, and I'll do that in a minute. But before I do that, what I'd like to do is just have a quick look around the 68,000 side of things, and if I log in as super user, and this will give me authority to do anything I like within the OS-9 system. This is similar to root on Unix or Linux. So if we have a look at what background processes are running, by typing in the command prox, this will tell me what background processes I loaded, and these were the numbers that were coming down the left hand side of the screen as we were doing the startup. You can see the top few are related to the operating system, like the shell, etc., the prox command that I've just started, and the others are related to the SCADA system, and you can see there's a number of CVUs in there, which are the calculation tasks, and the recover, which is trying to bring the graphics system online. You don't see the database in this list. That is not a process, it's actually a memory module. And if we have a look at what was loaded into memory at startup, these are the programs and modules that were loaded. If I do a more detailed listing, you can see I get all of the information related to every module or program that was loaded. And I won't go through all of these, but if we briefly have a look at some of the main ones, you can see we loaded the kernel, and that is 27.5 27,000 bytes, so that's 27.5K for the kernel. Very compact and very efficient. And if we look at the database that we loaded, that didn't appear as a process, but it is loaded as a module. You can see the database itself is actually only 17K, and the index to the database is only 78K. So the whole database, which in this system is around about 5,000 objects, only takes up about 100K, so very efficient. The only other command I'm going to run while I'm in the console is the M free command, and that will have a look at how much RAM I've got available. This was is a 2 megabyte system, and you can see I've got nearly 1 megabyte available for new modules or applications or whatever else. So you can see very compact. I'm not going to labour on the OS-9 side of things anymore. I'll do a little bit more on that in a sister video that I'm doing to this one, which is showing why I'm migrating from one OS-9 version to a newer version so that I can bring this product back to market again.
Now let's have a quick look at the hardware that I propose to use as the basis of my new development system. This box is a eBox 3350 MX from iCOP. The thing is very small, just to give you some idea. If I ring in a dollar bill, you can see it's really small. It's 3.5 by 3.5 by about 3/4. This is a full PC. It's actually a 586 processor or processor clone. And as you can see along the front, we've got a card slot, an SD card slot here. We've got 2 USB ports, mic in and headphone out, status light and switch. And on the back, if we have a quick look around the back, we have the power in, which is a 5-volt supply at 2 amps, Ethernet, VGA and another USB port. So if I quickly just pull the thing apart for those of you that are interested, you can see there's very few components, there's no fans. Obviously with the SD card, we don't need a hard drive, we'd use that as a hard drive. And quick look inside actually shows us that we've got a single board computer, as you would expect. Comes apart very easily. And if you look on the top side, we've only got one major component. This is a system on a chip, and it's basically got everything on this particular chip, including IDE, serial ports, floppy port, all kinds of peripheral ports that you'd expect on a PC. We have 2 chips here, which gives us 256 megabytes of DDR2 RAM, battery for a real-time clock, of course, and then the Ethernet IC. And if we turn it over, you see there's very little on the back. 2 more DDR2 port chips for primary memory, and of course the SD slot. You may have noticed that there's no serial ports actually coming out on the board, but actually if you look here, we've got pads on the board to put in the IC components and a header here to put in the actual DB9 connector, and the same on the other side. So in theory it wouldn't be that difficult to actually put in 2 serial ports as well, which is pretty useful when you're dealing with OS-9. The other stuff I'm not really interested in, the audio side, and that's basically it. Not much to it. Okay, I'll put the thing back together now, and you also may notice that it's actually got the 4 VESA mount holes. This is VESA Type D, which means it's about 75mm spacing. So this unit will fit conveniently on the back of a monitor, which I'll do a little bit later. But just to give you an idea why I want to use this, this is part of a range of equipment from a company called iCOP. And here we've got another version of this board. This is actually a similar device, a system on a chip module, but here we've got a motherboard with far more capability than the board I've just shown you. you can see that we've got two Ethernet chips here, so apart from the one on board we can have three Ethernet lines. We've actually got the ability, if you look here, and those already connected here and here, we can have up to 7 serial ports. We've got obviously the serial port here. This can be RS485 if we need. We've got the ability to put in 4 more USB ports, which in addition to this one here, gives us a total of 5. NIC interface, of course, VGA interface, again battery for the real-time clock. And on the back of this one we've got an SD card slot, a compact flash slot instead of the SD that we have on the other one. And just to show you one more unit that we've got, this is actually a panel PC. I don't know if you can see it too well. It's basically 1024 by 600, and again on the back we've got the same sort of thing, the Vortex single board computer inside the back here with a limited range of peripherals. So basically we've got a range of hardware all coming off the same basic design of SoC. Okay, so here we have the unit now mounted back on the back of a cheap Acer monitor, and as you can see it makes quite a neat installation to perform the function of a OS-9 development system. We need to get the operating system onto the SD card, and to do that we need a PC plus the software on the evaluation disk. Remember that the 3350 sees the SD card as the first IDE drive on the first IDE bus. So what I needed to do, I had to buy one of these cards which effectively makes the SD card look like the first drive on a bus, and this is connected to the IDE port on a standard computer. This computer is actually a Pentium P4 2.8 and it's going to run the standard operating system Windows XP with Service Pack 3. This is all important. I'll come back to it in a little bit when I've actually done the installation of the CD, evaluation CD from Microware. We also need a floppy, and again I'll come back to that when we've done the installation.
So when we insert the Microware evaluation disk, we get a start menu like this, and you can see there are a number of options. The only really one that we want to do is install the Microware for the x86. So if I do that, it won't take very long. We click on that and the installation will start. Take about a minute, but while it's doing that, I should say that we want the evaluation package, and just click all of the options, and it'll take about a minute. I should say that this only works on the Windows XP with Service Pack 3. Don't even think about Windows 7 or anything later or anything earlier. It also should be able to build a USB stick that's bootable, but it doesn't, and it also should be able to build a CD drive that's bootable, but it doesn't. So the only real option we've got for building a bootable device or a bootable system is using a floppy. And even here we can't use a USB floppy. We've got to use the basic onboard floppy that was prevalent in the early days. So we've got everything set up now. As I said, it only takes about a minute, and basically we've now got the development system included. If we come down to the main menu, we'll see that we look at all programs. We've now got Radisys as the option, and if we click on that, with the configuration wizard, we get the ability to actually try out the software and configure a boot device. And my boot device is going to be the floppy. So if I hit try, I'm going to select the board type. In fact, there is only one board type that works with this, and that's a PCAT. We create a new configuration. I'm going to call it Vortex. And we don't have a current one, so we've got to have a new installation. I could configure beginner mode, but I want to go through a few of the options and just give you some warnings on what you should be doing and what you shouldn't be doing. So if I choose advanced mode, create the boot file using advanced configuration options, and I hit OK, I then get a screen with a number of options, and what I want to do is go for configure, and the first thing I want to do is configure the main configuration. And here I've got a number of options also. What I want to do is leave as many of these alone as possible, but I need to disable anything that is not currently on my system. So for example, if I go for Ethernet and I don't actually have it, what I need to do is do not include the lower level hardware, and when I go for OK, that means I don't have any Ethernet, because the R6040 is not a device that Microware will recognize, and I don't have any other devices in the system. And that is the same all the way through this configuration. Happy with that, we could say configure and build an image. We get this particular one. We want to build the core boot and the boot file. We don't want to boot.
Now that we have a bootable floppy with all the drivers, modules, boot files, etc., I need to boot from that floppy to make the SD card that is going to work in my 3350 bootable. So make sure that once you put the SD card into something like this module that I acquired, the module sits on the IDE primary bus, and this is set to the master on that bus. So let's boot up the system from floppy now. Okay, you can see it's booting from the floppy. This will take probably about 30 seconds, maybe a little bit longer. And then once this is done, we've got to prepare the disk just like you would under DOS or any other operating system, and then format the drive and then copy the files over and make it bootable. So the process isn't very difficult. It's very well described in the documentation given on the evaluation CD. And as you can see now, I've booted up to the $ prompt. I've actually got into OS-9 from the floppy. So if I do some commands like mdir, you can see these are the modules that were loaded into memory when the floppy was booting. And if I change directory to the floppy, which is nominated as D0, and I do a dir, you can see that we've got commands directory, systems directory, and then some other files, first boot, sysboot, and the hard disk descriptor that we're going to use. So the first thing we've got to do is we've got to prepare the disk, and we do that using fdisk, which is the same or similar to the fdisk on DOS. It's -d equals /hc1 fmt, and we get a similar menu to the DOS fdisk. And of course, the first thing we need to do is create the OS-9 partition. So we choose option 1. We want to enter the size. We can choose whatever size we want. I'm going to have the whole disk, so choose that. And then we need to tell it what type of partition. I'm going to make it all OS-9. And now you can see that we've done that. If we escape, we've got to write the master boot record. Yes. And then if we escape, it says, do you want to save the information? Yes. So I've prepared the disk now, and now what I've got to do is format it.
Don't forget to make the partition active like I just did, and then use format /hc1 fmt to format the drive. Don't need to do physical verify, and then use the bootgen command that's detailed in the documentation.
So all we need to do now is put in the SD card into the eBox 3300 and start the system. We can see the system will go through its post, and basically we get the IPL, and I've got it to boot automatically, and so we're booting straight into the SD card, or the first drive on the IDE bus as it's seen logically. If I look at DIR, you can see that I've only got commands and sys on here, and if I look at M3, we have a look at what's available. You remember this is a 526 megabyte system. I've got 504 megabytes free. If I look at MDIR, you can see the processes that were loaded, and if I do a more extended one of that, you can see that we've got the actual sizes of all of the units. If I just put in first up T mode, you can see all of the actual modules and their sizes, and the only one I'm looking for is the kernel. And you can see on this system the kernel is 80.592 kilobytes, and if you remember on the 68,000 it was only 27.5 kilobytes. So you can see the size has gone up quite a bit. This is because this kernel is written 100% in C, and the Motorola one was written in assembler. But nevertheless, a kernel of 80K is really minuscule by today's standards.
So, why did I produce this video? Before I give you that information, I just want to say I have no association whatsoever with either iCOP, which is owned by DM&P, or Microware LP. So these are my own thoughts, and I'm not interested in selling their products. Why did I use the eBox 3350MX hardware? Well, I needed a 586 base machine, an IBM PC effectively. It's small. It's only 85 by 85 by 20. It's extremely low power consumption, consumes less than 8 watts. It has sufficient processing power. It's a 1 gigahertz processor, 512 megabyte of DDR2, and as much SD card memory as I want. And it's cheap. Currently the prices are around about $120. And then in terms of environmental, it's fanless, and it's got the correct environmental spec. It'll operate in temperatures of 0 to 70 as standard, and iCOP have got an extended range one that'll go from 0 to 85. Why use Microware OS-9? Well, I need the real-time operating system. It's compact, it's fast. The promise was that it would run very fast on this particular box, but most importantly I needed to get support for my legacy SCADA application, so that was the main motivation behind the Microware OS-9. So what are the experiences of putting OS-9 on the 3350MX? First, the bad points. Not necessarily bad, there's no major hurdles. But firstly, it's not a straightforward install. You must use Windows XP, Service Pack 3. Don't even think about any other Windows operating system like Windows 7. The Microware Wizard is very unforgiving with respect to the modules selected. And if you include modules that are not actually on the board itself to support those hardware components, then I think the thing just hangs. Also, I couldn't get a bootable USB or a bootable CD to work. That would have aided the process considerably, and that's why I had to use the small module that converts an SD card to an IDE hard drive. With the basic install, not everything's working. The Volari VGA and the R6040 drivers are missing. I don't see these as big problems. To actually do the drivers would probably only take a week or so's work. In fact, but both the sources for the Volari and the R6040 are available for Linux, and you can download those. So it might just be a simple matter of extracting the components and doing a bit of a port. And the major problem is that there's no real development environment. The evaluation disk actually comes with Hawk, which is less than friendly. Also, the evaluation will run out in about 60 days. So the problem is that by the time you've got your head around Hawk, you're basically out of your development time window, your evaluation time window. But what are the good points? Well, as you may have seen, the operating system is very fast on the eBox 3350, and of course there's migration to more powerful machines. It's very compact, and it's a rock-solid operating system. So what was my motivation to actually do this work? I had personal motivation, of course. I needed to assess the performance of OS-9 on the eBox 3350MX. I needed to assess the difficulty of porting my legacy software, and I did have a little bit with it, and it would appear that something like 80% will simply recompile, and I'm in good shape. I've obviously got to code all of the assembler, the 68000, and either turn that into C or make it x86 assembler. Motivation for a wider audience, I wanted to show that OS-9 could be affordable even for the hobbyist. The hardware and basic runtime license combined would be less than $300. But there is a big problem, and that is that the development seat prices must be addressed. Currently, the development seat price for OS-9 is around about $10,000 per user, and that is not going to fly with any kind of home hobbyist, and it will even put off small companies who may have looked at the operating system and considered giving it a try. So it really needs a more cost-effective runtime environment. In fact, possibly even free. The basic environments like Eclipse, the IDE is there, and all that needs to be done is a plug-in. So that's basically the video. If you're interested in conversing more, you can contact me on Keith at screamingpower.asia. If you want to get some basic questions answered, I can probably do that, and for the more difficult questions I can always forward them to people at Microware LP, etc. So I hope this was useful, and have a look on the YouTube for accompanying videos.